Hello everyone. Today I'll be talking about camera sensors in electronics. So, camera sensor sounds like a very familiar term, but how much do you actually know about it and its underlying technology? To start off, let's take a look into a bit of background. So, how it began was from the invention of the charge-coupled device by scientists in Bell's lab. It's a prevalent technology for capturing images, from digital astrophotography to machine vision inspection. The CCD sensor in itself is an analog device, but the output is immediately converted to digital signal by means of analog to digital converter. The discovery was from 50 years ago, which is not too long ago, when the realization that electric charge could be stored on a tiny MOS capacitor. As you can see in this image, it's somewhat of the size of maybe a business card, but nowadays it's almost as small as a 20-cent coin. So the discovery of the first digital camera sensor. The scientists involved were named William S. Boyle and George A. Smith. They were recognized for their contribution by the Nobel Prize, and in 1970 later on, they then made the first solid-state video camera. Here's a picture of them. On the left, there is William, and on the right is George. So, with the charge-coupled device, they transform patterns of light into useful digital information, and it's the basis of many forms of imaging. And I believe this image was taken in 1974. So the CCD technology makes use of the photoelectric effect as theorized by Albert Einstein, and for which they were awarded the Nobel Prize. The challenge when designing an image sensor was to gather and read out the signals in a large number of image points, pixels, in a short time. So, the technology. You most likely have a CCD device with you right now, your mobile smartphone. Light shining on a computer chip allows light to be captured for each pixel. So that technology is metal oxide semiconductor. So modern sensors are solid-state electronics devices containing up to millions to discrete photodetector sites called pixels. Traditional metal oxide semiconductors structure is obtained by growing a layer of silicon dioxide on top of silicon substrate, commonly by thermal oxidation, and depositing a layer of metal polycrystalline silicon. The first camera used CCD sensors, a charge coupled device, but CMOS, complementary metal oxide semiconductor chips, uses transistor at each pixel to move the charge through traditional wires, which offers flexibility because pixel is treated individually. And then there's a new type of sensor called QIS, quantum image sensor. It's relatively new, but what's more common these days are CCD sensor and CMOS sensor. So let's take a look at the comparison between CCD and CMOS. So CCD produces lower noise, has better control of light sensitivity, but CMOS on the other hand has better handling of blooming and is inexpensive and consumes less power. Today, almost all sensors in machine vision falls into one of these two categories. So let's dive into the theory. So to keep it very simple, a camera sensor functions in a way that light passes through the sensor, and it takes that light energy and converts it into electronic signals, which is what you know as images. So the photoelectric effect. Early on, scientists had thought light was made of particles around the 1600s, while others theorized light was a wave. Einstein determined that light energy is carried in discrete quantized wave packets. Thus, light could be simultaneously a wave and a particle. This theory resolved questions about relationship between light of different frequency and the theory of the energy of that light. The photoelectric effect is how optical signals are converted electrical signals and is the fundamental process behind the CCD cameras. When the light shines on a metal surface, typically the energy of that light will dislodge electrons from the surface in a phenomenon known as the photoelectric effect. This happens for all wavelengths of photoelectric energy, encompassing the full spectrum of visible light, which is at 300 to 700 nanometers. In essence, a CCD sensor is a slab of silicon layer, which are typically doped with the addition of other elements like phosphorus to alter its conductive properties. When light shines on a metal surface, typically the energy of that light energy contained in the photon will dislodge electrons from surface, known as photoelectric effect, which is sometimes referred to as photoemission. So the CCD technology is a digital camera electronic eye. It revolutionized photography, as light could now be captured electronically instead of on film back in the olden days. The digital form facilitates the processing and distribution of these images. It's also widely used in many medical applications and are also used in astronomical telescopes, scanners, and barcode readers. They also can be found in machine vision for robots, in optical character recognition, and in the processing of satellite photographs, as well as enhancements of radar images and meteorology. A good CCD can produce an image extremely dim light, and its resolution does not deteriorate when the illumination intensity is low, as in the case with conventional cameras. But most commonly right now would be CMOS, is what you'll find in abundance. I hope this talk creates a deeper appreciation of the technology around us, even though it's available in abundance. Thanks for listening. Hope you have fun in IEEE Wonderland.